Okay, now we are considering two equations here. So let us consider this body which is going already in a velocity of AVA. Now this is the time where you started the time interval and you ended the time here. So this is the interval of time t. So when we see this entire from here till this point, this velocity is going to be equal to VA into t. This is the distance here. The distance is VA into t. And what the distance here is x a at that time before the time t is equal to 0 from the origin here. So you get here the total distance from here till this point is going to be equal to xa naught plus vat. That is the velocity of va from the starting to the end. So you can write here as xa naught plus vat. These are two distance which is here together. Similarly, look at the body B, which has started from the origin here, but you started the timing over here. So time it ends over here at t. So what is the total timing velocity distance which is traveled from here to here? It is vb into t. This is the distance here, and the distance traveled here is going to be xb naught. So totally you get here from here till this point you get xb naught plus vbt. So this is also distance, this is also distance. Add both of them together. So xb naught, that is the first part of the distance, plus vbt, second part of the distance here. So this is the total distance here. So you get here as the entire lineup. Now if you wanted to see the difference here, okay, so it becomes here as xa, so xb of time minus xa of time. Difference, the difference of two equations, you will give you then value here xb of naught minus xa naught, this one, plus vb t minus va t. So you get the difference of both of them here. Now as you find the difference, that is already a minus sign is coming in between, so that's a minus sign here. Now you can assume this one as xb t minus xb naught. This is gone to the next side, minus xa minus xa naught. So this is gone to the next side. That will be equal to, so here it is gone to the next side, and this also has gone to the next side here in this one. It is equal to vb time minus va time. And also you can make this one as vb minus va of time t. So this is the relative distance which you get here. The displacement finally you will get here as relative displacement of b with respect to a, because b is subtracted with a. That is going to be called as vb minus va. Now if you want to write the next expression here, so you will get our expression here as relative velocity of relative displacement of b with respect to a divided by time. So time you bring it down, that is going to be equal to vb minus va. So this is called as the relative displacement of b with respect to a with respect to time is called the relative velocity of a with b with respect to a. So you get a final expression here. You can write this one as vba is equal to vb minus va. That is the way in which you can write. Similarly, relative velocity of a with respect to b, how can you write? It is going to be vab is equal to va minus vb. So that's the way in which it could be compared also. Now this can be written as, what is this one? Relative velocity of b with respect to a, and relative velocity of a with respect to b could be this way. So in short, finally, the velocity of B minus the velocity of A gives the velocity of B with respect to A. That is called relative velocity of the two bodies. So we are going to continue seeing the relative velocity. Now we are going to see the representation in terms of position time graph. We are going to draw a graph of position and time, and we are going to see how the relative velocity works for two bodies. So we know this formula already. We saw this expression VBA is equal to the relative velocity of B with respect to A is equal to VB minus VA. We will subtract both the velocities. That will give the relative velocity of one with respect to another. So the first case, we are going to see when two bodies move with the same velocity. When two bodies move with the same velocity, that means VA is equal to VB. We already know this expression. This is what the expression that we have seen earlier. This same VB minus VA. With respect of this one, if you can write the position change. The position change, position into time, and position into time is going to be equal to the position of the relative change of displacement with respect to time is going to be equal to VB minus VA. So that makes it quite simple for us. It is divided by time here. So you get here VB minus VA here. So when the two objects are moving in the same speed, what will happen here is this going to be equal to 0. VB minus VA is going to be equal to 0. So that's going to be XB of t minus XA of t going to be equal to 0. That means XB and XA will be of the same distance. You will find both of them having the same distance all the time. So that could be the final way in which we could look at it, because velocity is going to be equal to 0 here. How it could be represented in terms of a graph here. So the graph, if you wanted to draw the position time graph, this is time, origin, and this is going to be the position time. So called as X here. Now this could be the position of A, XA, and this could be the position of XB. So as the body moves, continuously moves, you will find this is going in the particular velocity here called VA, and this will also move in the same velocity called VB. Now you will find the graphs will be parallel here. You will find the graph going to be parallel here. Suppose there are two bodies here, maybe the same train itself we saw. I already said that one, some kind of an example. That last example that I said is, if this is going in 40 kilometers per hour and the next train is also going in the same speed of 40 kilometers per hour, after 2 hours, what you will see, both of them on the same position. For example, if this train is going in this speed here in this position, and next train is going here a little ahead, and there's already a difference in position here. The difference in that there is a particular distance is there in between. After 1 hour, both of them are going in the same speed of 40 kilometers per hour, and this also 40 kilometers per hour. So after 1 hour, what is the difference in the position you will find? Same distance you will find. The difference in the position will be same. So the position of these two will be exactly the same, whatever the time it's going to go, because the speed is same. You have seen also in the car racing, or maybe in the bike, in the roads that we see, if two cars are going at a particular speed and they are in a particular distance, so this car is in a particular distance and another car is also in a particular distance, you will find if both of them are going the same speed, the distance is maintained the same all the time. So distance will be same. So that is the first case of the position time graph here. Let us take the next instances here. So there is a relative velocity of here, one with respect to another. Now VB is higher in velocity and VA is less in velocity. That means the relative velocity of B with respect to A, VB minus VA, is a positive value, because this is higher and this is lower. Now when you consider this particular expression here, XB minus XA upon T, that's going to be the relative velocity of B with respect to A, that is the relative velocity of BA. Now what you will get here is you will get as a positive value, because this is going to be having an positive value here. So if you draw this one as a graph here, you will find this distance will be constantly increasing. The distance between these two will be increasing, because xb is going to increase more, this is going to be less. At all the time you will be seeing there is an increase of this one with respect to time. So let us see how this will be shown in term of a position time graph. So always write the x and y axis. So position time graph, here it's going to be your body A, and this is going to be body B, and we already saw body A is going in a less speed. It is going in a less speed like this, and body B is going in a very high speed. When body B is going in a very high speed, this is VB and this is VA. So you will find there is a gap is constantly increasing here. This gap was only less. This gap is increasing at different timing. So XB minus XA, this is going to be constantly increasing, and this is going to be always little more, not much with respect to the other one. So you will find this is a positive value here. Because of the positive value here, this is also going to be positive here. So you will find, therefore, the displacement, you can say displacement, or maybe you can say the position between the two bodies keeps increasing. When the displacement keeps increasing, therefore it is positive. The displacement is positive, hence the relative velocity of B with respect to A is positive. So you will find VB is greater than VA, and VB minus VA is equal to be a positive value. So this is the relative velocity with respect to one with respect to another when there is a positive value of relative velocity here. The last case we are going to see as when VB is less than VA. So B is going in a lesser speed and VA is going in a higher speed. This is a sense of overtaking one and another. There is a slow vehicle going in the front. You will be able to see the next person raising up higher and higher. You will be able to see maybe there is a car. An old uncle is going in a vintage car, and another fellow is going in a nice fast moving car, and he is going in 60, or maybe you can say it's 100, and he is going in 60. What happens here? After some time you will find the distance between them, it's getting smaller and smaller. This gap between them is getting smaller and smaller. At one point of time he overtakes, and then he zips down with a higher speed here, and you will see the distance is also, the gap is increasing more after overtaking. Before he overtakes here, you will be able to see this one. It is coming closer and closer. This distance is getting smaller and smaller. At one point of time, both of them, they are meeting each other, and then he goes in a higher speed, and the distance again it increases. So that's kind of situation which is here. So you can see this one as A and this one as B here. Now already we said B is going in a gradual speed. This is a gradual speed. Of course, there is a speed which is it is gradually it is increasing, and this is VB. And VA, this body A is going in a very high speed, and he is going to go higher. So this is VA. At one particular time, both meet each other. This is the meeting position. So you'll say point of meeting is this position here, and here this one you will be able to see it is going to be, the value is positive because there is a gap is there already. So the position is positive, and here the position is negative. So here the time of meeting is here. So what happens here is VB is less. So VB is less than VA. when VB is less than VA, you will find the position time graph. So you will get here XB T minus XB XA T upon T is going to be equal to VB minus VA, and this is less, this is greater, so it's going to be a negative value. If this is a negative value, what happens? This distance is going to keep on reducing, this distance is going to be keep on increasing, so it's going to be having a way in which it is going to keep on reducing the distance. At one point of time it meets each other and keeps moving ahead. So that's the way you will be able to see the distance initially decreases, meets, and then further it starts increasing. So that's the way you will find that relative velocity is negative. So VBA is equal to negative value of relative velocity you will find here. So this is position and time graph. Alright children, we have seen three cases. Case 1, both the velocities are same. Case 2, there is B is greater than A, and case 3, B is less than A. So all the three velocities and the position time graph has been done, and this will be coming in the examination. You need to explain how it comes and what are the expression which is based on this. Thank you.